Hey everyone, what we're going to do today is we're going to learn how to calculate pressure. Last week we talked about what pressure was in context and what pressure meant. We also talked about how the difference in area applies to pressure and what it does to pressure. Today we're going to actually calculate pressure. So remember last week we were talking about the equation for pressure, which is P equals F over A, force over area. So we're going to look at this first problem. The problem reads, a force of 20 newtons was applied to a desk with an area of 10 centimeters squared. What is the amount of the pressure? So you kind of like we did with the speed problems and like we did with the acceleration problems, we have an equation. We're going to plug our known values into the equation. We first have to ask, what are we being asked to find? We want to know what pressure is. So we're obviously going to use this equation. Then we look for our knowns. What do we know we have? I know we have 20 newtons. I also know we have an area of 10 centimeters squared. So now I have to figure out what each of these is. Well, I can look for the keywords, a force of 20 newtons, so I know 20 newtons is my force, or I can also tell by the unit used. Because the unit is newtons, I know that this is going to be force. So then I'm going to plug 20 where force would go, which is on top. So I'm going to plug 20 on top. I then see an area of 10 centimeters squared. So I'm going to take my area and put it where A would be, which is on the bottom. Now recall, this fraction sign means divide. So that means I'm going to take my force and I'm going to divide it by my area. So I'm going to take 20 newtons and divide by 10 centimeters squared. That should leave me with P equaling 2 PA, or 2 pascals. So recap. I looked for my unknown. I then picked the equation to use. I then found my knowns and I plugged them in where they went. Then I calculated and I got my answer, and I made sure to include the unit. If you want to write pascals out instead of writing PA, that's fine too. Now, my other big hint of advice to you is for our class, for pressure, I'm not going to ask you to find force or area. I'm only going to ask you to find pressure, so your unknown is most likely always going to be pressure. Okay, now we're going to go to problem 2. So the next problem reads, a force of 20 newtons was applied to a tiny piece of wood with an area of 1 centimeter squared. I then want to know what is the value of pressure. So again, the first thing I do, I look for the unknown. What am I being asked to find? What is the value of pressure? So I want to know what pressure is. Then it wants me to find my knowns. So I know, oh, a force of 20 newtons and an area of 1 centimeter squared. So now, like I did in the first problem, I'm going to plug my force where F is up top. I'm going to plug my area where A is, which is on the bottom. And I'm going to remember that I divide. I take my numerator and I divide by my denominator. So 20 divided by 1, pressure should equal 20 PA, or 20 pascals. This is exactly like our speed problems, exactly like our velocity, acceleration, and Newton's law problems. It's also going to be like density. They all have the common theme. You have an equation, you plug in your knowns, you find your unknown. So because we've been doing this all year, I'm confident that we are able to understand this. Before I go, I want to show you what we were talking about in the video and what we were talking about last week, but with numbers. So if you look at the first problem, I have a force of 20 newtons. I have an area of 10 centimeters squared. My area is pretty big in this problem. My pressure is 2 pascals. If you look in problem 2, my force stays the same. It's still 20 newtons, but my area gets much, much smaller. It's 1 centimeter squared. My pressure is now 20 pascals. This pressure is greater in problem 2 than in problem 1. That's because my force is the same, but my area gets smaller in problem 2. Because the area is smaller, the pressure is greater. If the area is smaller, if my area is bigger, and my pressure will be smaller. Now this is obviously if we have the same force. If our forces are different, then we don't have a simple black and white answer. This difference that we can clearly see. But because we took this variable and we made it constant, we had the same pressure, that means, the same force, that means our pressures are going to differ depending on our area. So just to recap, what we learned today was we learned how to calculate pressure. You got to find your unknown, make sure you have the right equation, take your 2 knowns, plug them where they go, and then perform the operation, which is division. Get your answer, and make sure you attach the proper unit. Today, what I have you guys doing is 5 problems all about calculating pressure. You do not have to show the work because it's harder to do on a piece of paper online. But if you take a separate sheet of paper and you handwrite them, all I need you to do is type in the answer on the document. If you can actually type your work and show your work on the document, that's okay too. But I do not need to see the work, I just need to see the answer. I hope you guys have a wonderful day. I will talk to you tomorrow.